All right, lesson 50 is going to be on compound interest. So we're going to take the stuff that we've done in the last two chapters with exponential equations and logarithmic equations and use those in word problems. And today's word problems will be compound interest. All right, so there's two compound interest formulas. These will be, you don't need to memorize these necessarily, but you'll probably use them enough that you'll know them. So regular old compound interest formula. So the problem would be phrased like you're going to compound interest once per year or twice per year or every month or every day or something like that. So A is equal to P 1 plus R over N to the NT. So A is going to be how much you'll end up with in the future after so much time. P is what you start off with. R is the interest rate, and that interest rate is going to be a decimal. So if it says 5%, you would put in 0.05 for that. N is the number of times it's compounded per year. So here's a chart over here. So for instance, if it said it's compounded every month, then N would be 12. This N and this N are the same. And then T is the time, and that time is usually going to be in years. The thing about it is that your interest rate and your time needs to be in the same time frame. So if your time is given in years, then your interest rate needs to be given in years. If your interest rate is given in months, then your time needs to be in months. So those two things need to match. Then we have compounding continuously. A is equal to PE to the RT. So A, P, R, and T mean the same thing as they did over here. E is not a variable, it's a number, like you learned in the previous couple of chapters. So you'll only use this formula when the problem specifically says you're compounding continuously. All right. Credit union pays interest of 6%, compounded per annum means per year. Compounded quarterly, so that means 4 times per year on a certain savings plan. If $2,000 is deposited in a plan and the interest is left to accumulate, how much is in after 1 year and after 5 years? So again, here's the formula. All right, so in this case, we don't know A. We know that P, how much you're starting off with, is $2,000. Your interest rate is 6%, so 0.06. You are compounding 4 times per year, quarterly. So that'll be 4. That'll be 4. The time in this case is 1. And this one's going to be exactly the same thing, except now this will be 4 times 5. So everything else will be the same as it was up there. Okay, now, because what you're solving for is already by itself, this you would just type straight into your calculator. Okay, so here is a demonstration of where all those things go. Plug that thing into your calculator and you'll get a little more than $2,100. Because you started off with 2,000, you should end up with a number that's bigger than 2,000. Now, if make sure it makes sense. If it's after 1 year and you put in $2,000 and now you have 3 million, that doesn't make any sense. Especially at something at 6%. If it's 6,000%, well, that's something different. But make sure that your numbers seem to make sense when you're doing them. And then after 5 years, you'd have just short of $2,700. Okay. If you're not getting this into your calculator, and you could use Desmos as well. If you don't know how to get those things either into Desmos or into your calculator, make sure that you ask. I would plug this one in down here and make sure that you get that number so you know how to use the calculator. All right, find the amount that results from investing a principal of $2,000 at an annual rate of 8% compounded continuously for a time of 10 years. Okay, so this is what we're starting off with. So this formula, because it's continuously, is the other formula from the first page. Okay, so we want to know how much we end up with in the future. P is 2,000. E, and then this will be to the 0.08 times 10. Okay, we plug that into the calculator, and you're going to get $4,451.08. Okay, so you a little more than doubled your money over that 10-year time period. All right, after 12 years, you have an account that has $16,928. Your account gets 5% and it's compounded daily, so 365 times per year. There is 365 days in a year. How much did you start off with in that account? Okay, so in this case, we're going to be looking for the P part. So again, there's your formula. So we end up with 16,928. We're looking for P. Interest rate is 5%. Number of times compounded is 365. And this is 12 years. Okay, then we just need to solve for P. This thing is just going to be a number. So because it's P times that, I'm going to divide that to the other side. So like so. Okay, so I take this whole entire thing, divide it to the other side. Now, if you want to take this and make this a number, make sure you go at least a handful of decimal places and then do 16,928 divided by that decimal. So you want to do it in two separate steps. That's perfectly fine. Or you can plug it in one shot. So you start off with $9,290.67. When you're, I should have said this earlier though, when we're doing money with this, round to the nearest cent. Unless directions tell you differently. It might tell you to round to the nearest dollar, but typically we'll go to the nearest cent. I would again plug this one into your calculator and make sure that you can get that. And if you're having a calculator issue, then ask me. All right, what annual interest rate, compounded quarterly, should you seek if you want to double your investment in 6 years? All right, so quarterly is 4 times per year. Now we want to double our investment. It doesn't tell us how to start that off. So how much do I start off with? How much do I end up with? Well, as long as you end up with double the amount, it actually doesn't matter. So what I'm going to do is I'm going to start off with $1 and end up with 2. You could start off with $10 and end up with 20. You could start off with $14 and end up with 28. It doesn't really matter. The problem will end up working out the same. So I'm going to start off with $2. I'm sorry, I'm going to end up with $2 and start off with 1. Okay, I'm looking for what that rate would be. I'm compounding quarterly for 6 years. Okay, so I'm going to take this thing and solve it for R. All right, so that's what these steps are going to be here. All right, so there's your formula. So I need to get R by itself. So the order, the one, since this is 1 times. Now, if I did, say, 4 and 2, the first thing I would do is divide both sides by 2. So no matter what 2 numbers I put here, I'm always going to end up with a 2 in this spot when I'm doubling. And if it was tripling, I would always end up with 3. And if I'm quadrupling, I'd always end up with a 4 there. Okay, so the order that I'm going to move this in is exponent first, this 1 right here second, and this 4 last. Okay, so this 1, again, you divide both sides by 1. That 1 goes away. All right, so when I do the 4 times 6, I'd have 24. So to get rid of the 24, I'd have to do, like if this were squared, I would do the square root. So I'd have to do the 24th root, but I'm going to write it this way right here. Okay, so if I do both sides, see that there, to the 1/24th power. 24 times 1 over 24 gives you 1. So I end up with 2 to the 1/24th over here. So this is an exponent, which would be the same thing as the 24th root 2. So again, it's kind of like doing a square root of both sides, except I'm doing a different exponent with it. I would leave this alone. I would not take that and plug that into your calculator. It's going to be an ugly decimal. I would do it at the end. So now this is what you'll have when you do that. Then I would subtract 1 to both sides, and then I would multiply both sides by 4. This, I would take and plug into the calculator. When you plug that in, you'll get 0.11 and then decimals after that. So because I want to write this as a percentage, because it's the rate, And let's go one decimal place for all our rates, unless directions tell you differently. You'd have 11.7%. Okay, so this one is a continuously one, so same idea, except now you're using the other formula. So I want to double my investment, so 2 and 1 at RT. Sorry, I wrote that terrible. Should be as an exponent there. Okay, so that would be the numbers you'd fill in those. Okay, so this would be doubling, this would be tripling. The problem is going to be done exactly the same way. The nice thing about this is if I ask for both, notice when you get down to the end here, and I'm going to walk through this in a second, that this and this are exactly the same, except now doubling, tripling. So you've done all the work already, what is what I'm saying, you don't have to do it twice. So R times 6 would just be 6R, 1 times E is, 1 times this is just that. So now we're going to do a little logarithm trick here. So if you remember from the last chapter, when I'm trying to solve for what's in the exponent, do a logarithm. And in this case, because it's E, I'm going to use ln. You don't have to, but it just makes it simpler if you do, which I'll show you here in a second of why. That allows you to move the 6R to the front. ln E, natural log of E, is the same thing as log base E, and log base E of E is equal to 1. So that's why I did ln to begin with. Divide both sides by 6, and you got your answer. And then for tripling, same idea, except now this is going to be a 3 instead of a 2. All right, so that's compound interest, section 50. Let me know if you have any questions.